Okay, this is my new screen viewer on my new tablet. We'll see if we like it. Okay, so this is a BC 2008 multiple choice. Let's see, numbers 11, 10, and 11 for now as we're testing it. This is also a write-on to a PDF, so maybe I'll also be able to post it to Google Classroom so you can see the written solutions. Okay, so what is the tangent to the graph at the point? Okay, so you got to think, what does that make you think of? I'm thinking that makes me think of the derivative. So how do you take the derivative of this? So 2x dx. I think you guys like the version when you put the x's by it. And then this is a product. First times the derivative of the second plus the second times the derivative of the first. These are actually called differentials. 2y dy equals 0. They're not actually called derivatives. But the process is still called the derivative. Okay, so I usually like to put my dy's on the left side. So this term right here, this term right here, like my dy's on the left. I like my dx's on the right. So that would be what? Negative 2x dx. And then minus my y dx. And then dy, x plus 2y equals dx, negative 2x minus y. And then you need dy dx. Okay, so dy dx. So dy dx, you're going to remove this piece right here. Let's see how easy changing colors is. Oh, looks pretty good. Divide by this, divide by that. And then we get as our answer negative 2x minus y over x plus 2y. And then they want the slope at the point 2, 1. So now we're going to substitute into 1, negative 2 minus, and then I remember me doing a problem like this in class, and then you guys said I plugged in the letters in the wrong spot, so I need to be real careful. Okay, so x equals 2. It's going to go where the x's are. And then it says y equals 1. I'm going to put that where the y's are. Okay, so let's not make that error. So this is negative 4 minus 1 over 2 plus 2, negative 5 over 4. So negative 5 over 4 looks like B. Does it say anything about normal to the curve? Okay, remember normal is perpendicular. So let me just do a quick what if over here. Okay, so what if? First of all, what if it just wanted the equation of the tangent line? Okay, so what if it actually wanted a tangent line? Okay, so if it actually wanted a tangent line, we would do y minus the y value of the point, which is right here, equals the slope times x minus the x value of the point, which is right here. And then this is the slope. So remember your formula, y minus y1, mx minus x1. That's if you want the equation of any lines. Now, if you wanted a normal line, remember normal is perpendicular. So your point would be the same, but your slope would be different. So how do you make a slope perpendicular? Or how do you make a line be perpendicular using the slope? Remember, you flip it and change the sign. So that would be a normal line. What if? Sounds good. Okay, let's see. This is so cool. So the work stays with the problem, I guess. It's kind of exciting. Okay, so this is a new app I'm using to make a video. So we'll see if we like it. Okay. Let's see, 11. Let R be the region between the graph and the x-axis. For x equals 3, the area of R is. Now we are on the non-calculator section, so you might be looking at this and thinking, how in the world am I going to graph it? Okay, and the x-axis for x is greater than or equal to 3. Okay, so let's see. If you don't remember how to graph it, doesn't matter. Let's plot some points. Okay, so let's plot some points. So let's make a little table. Usually I don't write the table officially. I just do it kind of in my head. So, but it's nice to write it down. So especially if I'm kind of communicating that to you. Okay, so this would be 0 and then e to the negative 2 times 0. So that's e to the 0. E to the 0 is 1. Then if I substitute in a 1, that's e to the negative 2. Let's substitute in a negative 1. Negative 1 would be e to the positive 2. Remember, e is approximately 2.7. You could really approximate that to be 3, just for your graphs purposes. Okay, so 0, 1 is a point. And then 1, e to the negative 2 is a point. So e to the negative 2 is like 1 over e squared. So we're going to just call that 1/9. It's really more about like 1/7, but 1/7, 1/9, we're going to graph it in the same spot, which is going to be right here. Let's see where my eraser is on this new program. 1. Okay. So far it looks like this. Goes down, there's an asymptote there. And then negative 1 is e squared. That's about 9. That's up here. So here's my picture. I'm probably going to want a zoomed in picture, but at least this is the beginning. And the x-axis. Let's make the x-axis in another color. So here's the x-axis. There's the curve. X is greater than or equal to 3. So 3 is here. And then we're going to go this way. Okay, so this is a BC question. Now, I wasn't able to tell it was a BC question until I looked at the region more carefully. So the region is an infinite region. Okay, so this is the integral from 3 to infinity because they want everything to the right. And then they did say area. So area is y top minus y bottom, or x right minus x left. So I'm going to use y top minus y bottom. Y top is e to the negative 2x minus y bottom. Y bottom is 0 because it's the y equals x curve. Don't square it. Don't put a pi because we're not doing volume. Okay, so this is 3 to infinity e to the negative 2x dx. Okay, so this is a BC topic, not an AB topic. We need to take the antiderivative of that, but we also need to use our notation. Since your 2020 test is notation is going to be important, we need to set it up like this. So this is an improper integral. Let me move and my equal sign to give myself a little bit more space. So you have to do limit as b approaches infinity of e to the negative 2x dx. Okay, so the antiderivative of that, you can do u substitution if you want. But since the du is a constant, you can just put negative 1 over that number in the front. You can take it out of the limit if you want. Limits go in and out of these things. And then that would be e to the, I think I'm going to keep it in actually. I think that looks too strange for me to take it out of the limit. Okay, so e to the net, you know what else I'm going to do? Sorry to be indecisive, but I like to work down. Okay, so we'll keep the limit. B approaches infinity, negative 1/2 e to the negative 2x from 3 to b. And then I do like the b substituted in, minus negative 1/2 e to the negative 6. And this is the limit. That's kind of neat. It's auto-saving my Adobe write-on. It's kind of cool. Okay, so this is negative 1/2 e to the negative infinity. Okay, I'm going to write that over here. E to the negative 2 times infinity, which is e to the negative infinity, which is 1 over e to the infinity, which is 1 donut, and lots and lots of people. So this is near 0. Okay, now this, I don't know if I would write it. You know, officially in a college class, I'm not going to write an infinity substituted in. So it would be better for me just to write this. On the AP, I don't think they're going to take off points for that, though. E to the negative 6. And that, I believe, is the answer. So let's go check. Okay, their answer is not in my format. So 1 over 2 e to the 6th looks like answer choice A. very cool. See what you might have missed. Okay, so take a look, see if you wrote everything down that I wrote down. So you think you're good? I'm going to try to go to the next page on this PDF creator. So we'll see if it keeps it. So let me go to the next page. Okay. We'll see. I think my video is still going. I think we're still good. It's funny because the video bar was right above my save button. So we'll see. Okay, which of the following series converges? We're still on this one. 2008. Converges for all real numbers. On the new test, some of these might not still be on it. Actually, this whole question is on it. We're okay. What do the factorials remind you of? Which test? So remember we had our list of all the tests. So this is the ratio test. Whenever I see factorials, I think of the ratio test. The ratio test is still on there. This one here reminds me of n to the 1/2, right? So that seems like it might be related to a p-series. The only thing is the x. See this x in here? This x in here definitely changes things up from our normal. I'm still going to use the ratio test. Technically, this is an interval of convergence, so I don't know if they took it off this year, but it really is just asking me to do a ratio test. So perhaps this is on, perhaps this is off. Let's see which one I think converges. I think if there's a factorial in the denominator, then it's likely to converge. So I'm going to look at D first. Okay, large things in the denominator are more likely to have things converge. So I'm going to look at D. So I'm going to try D. I'm going to try D with the ratio test. So let's see. Oh, this isn't the pen that comes with my tablet. It seems to be working fine though. Okay, so let's do limit. So this is the ratio test. Limit as n approaches infinity. And then remember you do an plus 1 at the top and a1 at the bottom. There is an absolute value. Okay, so an plus 1 is e to the n plus 1. I'm working on D. X to the n plus 1 divided by n plus 1 factorial divided by e to the n, x to the n over n factorial. Limit as n approaches infinity. Let's see. So nothing quite cancels yet. So let's change it to limit as n approaches infinity. E to the n times e to the 1, x to the n times x to the 1, divided by n plus 1 factorial, times reciprocal of the denominator, e to the n, x to the n, chop, 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 chop. Okay, let's see what we have. I'm going to expand this factorial to this. Remember, I'm going to write this to the side. If you have 10 factorial, you could write 10 times 9 times 8 times 7, and at any point you can stick a factorial on it. So what I just did on that one is I did 10 times 9 and said, oh, and all the rest. Okay, and that's where I just wrote n times n factorial. E times x, n factorial. Chop, chop, absolute value. Limit n approaches infinity. Okay, now the e I can take out, and the absolute value of x I can take out because they don't have n's in them. So they're really constants. E is actually a constant, and then x is a constant with regards to n. So this is 1 over n plus 1. This is 1 donut over a billion people. Remember, with limits, we're doing donuts over people. So that would be 0. So that definitely goes to 0. So if this goes to 0, then e to the times 0 equals 0. And this is rho for the ratio test. When is that less than 1? I would say always. So we pick the right one. So this one always converges. Now I only use the ratio test. So it's possible that it's on the new AP. Possible that it's not on the new AP. I'm not sure. Okay. You know, there's no timer on this one to let me know how long I've been talking. So I don't know. Okay, so let's just do one more, 13. So 13 makes me feel like it's top heavy. So let me show you how I think of this versus D over A plus B plus C. To me, this one feels stable. More things at the bottom. And this one feels wobbly. The wobbly one is when you can distribute. Okay, so you can distribute that to be A over D plus C, B over D plus C over D. Officially, it's called distributing the division. What you're really doing is you're putting 1 over D, A plus B plus C, and then you're distributing the division. Okay. So when I see 13, that's what I'm thinking. I'm thinking distribute the division. Okay, dx integral 1 to e, that would be x plus 1 over x dx integral 1 to e. Antiderivative x squared over 2 plus ln absolute value of x from 1 to e. That's e squared over 2 plus ln absolute value of e minus 1 squared over 2 plus ln absolute value of 1. Okay. So that's e squared over 2 plus the ln of e minus a half minus ln of 1. Okay, so let me remind you over here. Let me change colors. Some math analysis, pre-calc stuff. Ln of e means there's a base. There's a base here of an e. And what it means is hold on, let me go back. It means e to the question mark equals e. And that would be 1. So ln of e is 1. You probably just memorized that. Also the ln of 1. So its base is e, so that's e to the question mark equals 1, and that would be 0. So the ln of 1 equals 0. So this is 0, and this is 1. So my final answer, and it looks like I can't scroll below this, but that's okay. So that's e to the second over 2 plus 1 minus a half would be plus a half. So that would be the answer. And the answer then, okay, so the answer then is I can add the numerators and keep the denominator the same, which would be answer choice B. Cool. I should circle back the other answer choice. Let's see. D. And I wonder if I can go back to the other page. I'm going to try. Let's see. Back arrow. Okay, that's kind of cool. A and B. Okay, so we'll see how this works. I'll upload this and we'll see if we like it. And then I'll also upload the PDF that has all the writing on it. So that's kind of awesome. Sounds good. Talk to you later.